Good morning. How are you? Here's our first attempt at a little content review. This is going to be just basic molecules and water, especially. I'm going to try to get it done in my allotted 512 megabyte limit for this. Um, if you get time, and I'd like you to read this part here. This is from a book by Carl Sagan 24 years ago, and it really hits the nail on the head with lots of issues today about how important science is. And I was actually, it's just 2 weeks ago, I was in Tallahassee and having a science conversation in a bar. And right around the corner of the bar from me were sitting a gerund and an infinitive, drinking to forget. See, that was such a good setup, and that was such a good one. I keep bringing you this solid gold. So here we go. You ready? So here again, we're looking at the syllabus, and here you see these are those science practices, describe characteristics of a processor represented visually. They might give you some kind of concept with a diagram or something. In fact, they're going to. Today, these are the two we're looking at. The elements of life, pretty simple, and the structure of water and hydrogen bonding, which we have been going over so much. This should be pretty quick and hopefully just all review for you, okay? These other four we're going to get to in the next set of slides or two. So here we have a little bit more of a breakdown, and here is where they tell you what you're going to need to know. So this is what I want you to pay close attention to as we get ready for this test. Describe the composition of macromolecules required by living organisms, and they tell you in order to grow, reproduce, and maintain organization, you need to eat your lunch. You need to exchange matter with the environment, right? You need to take it in, you're going to spit it out. So they then just focus on three kinds of atoms here. That means that's all they're going to ask you about: carbon, nitrogen, and phosphorus. And all they're going to ask you is this: what is their role? Their role is to be the building blocks of molecules. What kind? Carbon, all the organic molecules. Nitrogen, I know my face is blocking this, but I can't figure that out. Nitrogen, proteins, and nucleic acids. Phosphorus, nucleic acids again, and lipids, like phospholipids, right? And you don't want to get those mixed up. No phosphorus in proteins, for instance. So here we have that slide with that simple thing. Here's these other elements, right? But these in red are the ones that they put in the syllabus, and they're the ones that they're just going to ask you about. And that would be very little to ask you about. So now we have bonds. They're not going to ask about ionic compared to covalent kind of bonds, but some of this bonding might come into how these molecules work in biological systems, like if the bond is nonpolar, then that substance is not polar, not charged, and it can easily pass through the lipid part of plasma membranes. And that is a big concept in the cell part. And so now we get to water. We get to bonds that are polar, right? Explain how the properties of water that result from its polarity and hydrogen bonding affect its biological function. These are what they're going to ask you, right? So living systems depend on these properties of water that result from polarity and hydrogen bonding. Hydrogen bonding results from polarity, right? What are they going to ask you about? Hydrogen bonds causing cohesion, adhesion, and surface tension. But then they're going to maybe ask you how those things affect their biological function, which is a little more vague. So we're going to tie in a few things. All of this should be hopefully reviewed. So here we have your water molecule, right? Since the sharing of electrons is unequal and the oxygen is more electronegative and gets more of them, it's got two pairs of unshared electrons, which make this end a little negative and these ends of the hydrogens a little positive. To be able to explain that diagram, right? This is the figure they might give you, and then how that results in some kind of property like cohesion, right? These hydrogen bonds that can form between polar kinds of molecules. Here you have a water and an ammonium, right? And here the hydrogen bond is between the positive part of this and the negative part of that. And so there you have your classic hydrogen bond. What does that do for living things? Well, again, this is what they put specifically in the syllabus, these kind of three things. Surface tension to me is a really small one of these. I'm surprised they put it in there. You know, bugs can get on the surface of water because of surface tension, and a few other things are due to that. But what results from cohesion and adhesion is these things, and those are the most important properties of water. Even though they didn't name them, I can't imagine what else they're talking about. So here we go real fast again. There's your water molecule. Here we have the idea, but plants have been taken out of the syllabus even before it was cut down here. And so what we described as the combination of cohesion and adhesion, and when water evaporates out of a plant, it pulls up a column of water molecules because they cohere to each other, and their adhesion to the walls of this xylem tissue also pulls them up. There you have two different things, capillary action and transpirational pull, that both are due totally to adhesion and cohesion, which are due to hydrogen bonding, and that's due to polarity. Now we've covered all the words in the syllabus. So here's just more of what we said. Um, Here's again the temperature moderating ability has to do totally with cohesion. The fact that they stick to each other means that they have a high specific heat. This term didn't make the syllabus this time around. It used to be, but it wouldn't hurt if you could throw that in there if you were talking about why water can absorb temperature change and therefore cause living things and living environments to stay at around the same temperature. And again, all that is due to its hydrogen bonding, which is due to its polarity. So since you and other organisms and the earth itself, like ecosystems, are composed of a large percent of water, this high specific heat allows it to help keep temperatures moderate. Why is that important? This is the life thing that we get more into in the unit with enzymes, and where reaction rates and things become important. If it's too cold, there's not enough movement, no reactions happen, or not enough reactions happen for that thing we call life. And if it's too hot, this is where bonds break, proteins denature. This now bleeds over into our next unit as well. So here you have the idea that this energy that it takes to evaporate water, the heat of vaporization, helps keep things cool when water evaporates off their surface or out of them, like with plant transpiration and evaporation of your sweat. And here you have the ice thing. They didn't bring this up at all, but it's a property of water, and it's due to cohesion and hydrogen bonding, and that is the less density that ice has compared to liquid water causes it to float, and that means in the winter lakes that float, or even oceans, if it's like an ice age, that freeze from the surface down, aren't going to freeze all the way down in water, and therefore life will be able to still exist, water in its liquid state. So the ability of water to connect to other things, that's adhesion, and pull them apart, therefore making these ions available for all those kind of things that ions can do, like going in and out of membranes with chemiosmosis and things like that. This is a big factor, but they don't mention solvent ability right in this part of the syllabus, or really anywhere. But there you go. And so this is